One of my videos did not render properly, and we're going to redo it. Fall 20, test 3. We're supposed to place the following bases in order of increasing basicity, weakest base first, and explain. We need to look at all the conjugate acids when we do such questions. So let's just quickly run those by. We have diethylammonium ion. We have ethylammonium ion. We have diisopropylamine. And yes, this is LDA, lithium diisopropylamide. We have guanidinium is the conjugate acid here. And we just did a discussion of why that is a very stable ammonium ion with its extensive resonance. We got a pyridinium conjugate acid over here. Yes, the plus charge lives on an sp2 nitrogen. That's not as good as sp3. We'll put that in our answer. We have two imidazoles. So they both have resonance stabilization. You've got to make sure you protonate the right nitrogen. In this class and in every biochemistry class you ever take, imidazole is a very common base in biochemistry. Do not protonate using the lone pair that's needed for aromaticity. Don't use that pair. Use this pair down here. And similar story here, almost the same species. It's got an extra group on it. And let's talk about pKa's. Well, some of these we're supposed to know and some we're just supposed to have in order and come up with a reasonable guess. Roughly 10 and 10. Which one would you put a little above 10? Which one below? Well, this is stabilized by the best combination of hydrogen bonding and hyperconjugation. So it doesn't want to react as much as this one. So as an acid, pKa is a little below 10. And we'll put our pKb's up here. Remember, for a conjugate pair, pKa plus pKb is 14. 4. This will be 4, but up. And in keeping with our previous discussion, yes, a secondary amine is a better base than a primary or a tertiary. This is an anion. It's incredibly reactive. It's the only anionic nitrogen here. And the pKa of a normal amine, not an ammonium, an amine is 40. So the pKb, 14 minus 40, negative 26. I don't think you're going to have a number that negative. Now remember, the pKb is 0. It's one you might want to memorize for a guanidinium. Guanidine. Guanidine pKb 0 means the guanidinium, which I misspoke a second ago, the conjugate acid is guanidinium, is a 14. Now pyridine, remember, you've got it in your mind. You've got it in your mind here. You've got strongest base is now you know it's guanidine. And then the next best are the alkylamines. And then the next best are the imidazoles. So just remember pKb, pKa 7 for both the imidazole. We don't have to write pKa. All the reds are pKa's. 7 and pKb 7. Now this is going to be part of my answer here. The reason why this imidazolium is more stable than the one to the right is it has this extra resonance. Extra resonance compared to this one, which doesn't have that. So if I had to say, okay, got extra resonance stabilizing the ammonium ion, that means it's not as reactive. It's not as strong an acid. 7-Up. Oh, there you go. Trade rate, copyright infringement there, 7-Up. And now you just have to remember that the pyridine is not quite as good a base as an imidazole. So, hey, I don't want you to memorize, but you have to have them in order. And you already know that the imidazoles are 7, and this is a little worse. Sorry, this here is a little worse a base than these two. Just 8 sound good? I just put a roughly 8. That makes this roughly pKa roughly 6. And now we're ready to put them in order and then do some explaining. The most negative is the strongest base, so we're going to go with 3 as the strongest. The next closest to 0 is 4. And then going up, we have these two 4s. Lower is stronger, higher is weaker, so 1 is better than 2. And we'll talk about why. And then we're going up to our 7s. And we already explained that, well, if this is a more stable acid, that means the base is less reactive. So I'd have to put VII as better than VI. And our worst in this example is the pyridine. So we got them in order there. And in terms of explaining, we've got these two here. The secondary N plus has the best combination of hyperconjugation. I'll accept that short form and then I'll lose my screen for some reason. Conjugation and H bonding, hydrogen bonding. It's not quite as good hydrogen bonding here as it is here because there's more H's over here. But the fact that there's 2 alkyl groups to stabilize the cation via hyperconjugation is better than the 1. So that's good for these two. There's your pink explanation for those two. And for the last one, 3, I'm just going to say quite blatantly that anion N most reactive. All the other nitrogens are neutral. That should make sense. And now we're going to talk about the, we already talked about this. This picture says the answer to me. I got resonance. I wrote something. So I don't have to talk about those two. You do have to talk about the fact that all 3 of these are sp2, which makes them in a different league, different realm, different category than all the ones with lower numbers up here in green. Lower than, sorry, higher numbers than these in green, so less basic up here. And you have to tell me that you understand that sp2 N plus not as stable as sp3 because you're bringing the plus charge closer to the nucleus with a 33% S characteristic of sp2. And then you have to finish off by saying this is extensively resonance stabilized. That means it's the easiest conjugate acid to make. It means it came from the strongest base. Finish writing before you keep talking, Dr. Whitaker. Extensively resonance stabilized. And I believe this is a adequate answer. A little different than the, on the same document, I included the one with the busted video. They're pretty much the same, but you know, hopefully this one worked. We'll see. And it was nice doing business with you, and we will see you on our next SDQA. Take it easy.